In this module, we'll turn AI security principles into Azure architecture decisions. Zero trust across identities, data, apps, and infrastructure. Secure network controls, continuous monitoring, and governance alignment through TOGAF ADM deliverables. So far, we've built the foundations: enterprise architecture, ADM practice, and Azure AI platform design. Now we connect that work to security architecture by turning AI risks into zero trust controls, secure network patterns, and monitoring decisions. Enterprise AI creates value by connecting data, models, prompts, APIs, identities, and cloud services. Each connection also creates a possible path for attack. Security architecture turns that risk awareness into practical controls, so organizations can protect innovation without slowing the business down. Zero trust starts with a mindset shift. Nothing gets a free pass, even inside your environment. For AI platforms, every user service account, model endpoint, pipeline, and automation step must prove who it is and why it needs access. Verify explicitly using identity, device health, workload identity, location, and risk signals. Apply least privilege so access is narrow, temporary, and purpose-based. Assume breach by designing for small blast radiuses and fast detection. Then monitor telemetry and behavior continuously, because trust is not granted once. It is re-earned every time the platform is used. In Azure AI, identity becomes the control plane for almost every security decision. Users, admins, applications, services, pipelines, and workloads should authenticate through Microsoft Entra ID and receive only the permissions they need. For Azure services, managed identities are preferred because they remove stored secrets and long-lived credentials. Access is governed with RBAC across subscriptions, resource groups, storage, Key Vault, AI services, and monitoring. Keep human accounts, service identities, privileged admins, and workload identities separate, so authorization, conditional access, and auditing stay clear and enforceable. Least privilege reduces blast radius. Every user, service, pipeline, and model workflow should receive only the permissions it needs, for only as long as it needs them. In Azure, prefer specific RBAC roles over broad owner or contributor access. For administrator tasks, use privileged identity management, so elevation is approved, temporary, reviewed, and auditable. Apply the same discipline to secrets. Store keys, certificates, connection strings, and tokens in Key Vault, not in code, notebooks, or configuration files. Then rotate credentials, monitor access patterns, and investigate unusual secret usage quickly. Assume breach means designing as if one identity, app, pipeline, or endpoint will eventually be compromised. Segmentation keeps that failure contained. Development, production, business apps, AI services, and sensitive data should not all share the same trust boundary. Use separate subscriptions, resource groups, VNets, subnets, route tables, and policies where the risk justifies it. Critical assets like model endpoints, vector stores, datasets, Key Vault, and monitoring workspaces need tighter isolation. The goal is straightforward: allow only the paths required for business, block lateral movement, and prevent one compromise from becoming a platform-wide incident. For AI workloads, network design is about controlling every path data can take. Separate web, AI, data, and integration components into clear zones based on sensitivity and trust. Use network security groups to allow only required subnet and interface traffic. Higher risk flows should pass through inspection, such as Azure Firewall or a security hub, before reaching models, APIs, or databases. Segmentation is only one layer, though. Zero trust also depends on strong identity, least privilege access, application protections, logging, and continuous monitoring to catch misuse quickly. Private endpoints and service endpoints both reduce exposure, but they work differently. A private endpoint gives the service a private IP inside your VNet through private link, so access can stay on private addressing and public access can be disabled. That is the stronger pattern for sensitive services like storage, SQL, Key Vault, AI services, and registries. Service endpoints are simpler. They let Azure services recognize your VNet as the source, but the service still uses its public endpoint model. Choose based on isolation needs, DNS impact, and operational complexity. Think of perimeter protection as the controlled front door for your AI system. Public traffic should terminate at Azure front door or application gateway, with WAAF rules inspecting requests before anything reaches the application. That helps block common web attacks like injection, cross-site scripting, and protocol abuse. APs then add identity and usage controls. OAuth, authorization checks, throttling, schema validation, and request filtering. For GenAI workloads, go further by validating prompts, detecting abuse patterns, limiting request rates, and filtering outputs. The principle is simple. Expose secure ingress paths, not backend AI or data services directly. Egress control makes outbound traffic intentional, not accidental. Identify the destinations each AI workload, notebook, container, or integration service truly needs. Then force that traffic through Azure Firewall or another approved inspection point, rather than allowing direct internet access. Apply policy with FQDN filtering, threat intelligence, and allow lists. So approved services work and risky destinations are blocked. Finally, log everything and alert on unusual patterns, such as large transfers, unknown domains, or unexpected regions. Review exceptions regularly, because every new outbound path can become a data leakage path. Effective monitoring treats every layer as a telemetry source: identity sign-ins, network flows, application events, data access, AI service activity, DevOps changes, and security alerts. Azure Monitor and Log Analytics provide the common collection layer so teams can query operational and security signals together. Defender for Cloud adds posture management and workload threat detection, helping identify misconfigurations and active attacks. Sentinel correlates events across sources, runs analytics, supports hunting, and drives incident response. The goal is not more logs. It is reliable evidence for fast decisions. Defender for Cloud turns security posture into an operating model. Assess, remediate, and protect. Secure score and compliance views show where the environment stands, while recommendations translate gaps into actions teams can prioritize. Workload protection plans extend that model across servers, containers, databases, storage, and cloud-native services, adding detection for threats and risky configurations. The value is not only finding issues like public exposure, missing encryption, weak access, or limited monitoring. It is connecting those findings to governance, risk decisions, and engineering backlogs, so remediation becomes measurable, owned, and aligned with architecture standards. Sentinel turns scattered security signals into an operational response process. It collects telemetry from Azure, Defender, Entra ID, firewalls, apps, and external systems. Analytics rules correlate activity across users, networks, data, and AI workloads to identify patterns that a single log might miss. When suspicious behavior appears, Sentinel raises alerts and groups related alerts into incidents. Analysts investigate with graphs, workbooks, and hunting queries. Playbooks can then automate action, disable an account, isolate a resource, notify a team, or create a ticket. Finally, lessons learned improve future detections. The core message is simple: secure enterprise AI as part of the architecture lifecycle, not as an add-on. Start with zero trust. Verify, limit access, segment, and assume breach. Reduce exposure with private connectivity, firewalls, secure ingress, and controlled egress. Then monitor continuously for evidence, detection, and response. Next, we extend this foundation into privacy, responsible AI, and threat modeling.